Assalamu alaikum, dear friends and students. Today we will discuss the solution of assignment 2 based on functional groups, types of carbons, oxidation levels, oxidation states, and hybridization. So let us begin. And the first question of the assignment was to encircle the functional groups and name that. In this connection, we were given four different structural formulae. So let's discuss the first case, but before discussing, let us know what the functional group is. Basically, functional group is the structural unit that is responsible for the chemical reactivity. In fact, we have different reactive sites in a molecule, and each individual reactive site is a functional group. The whole molecule is not a functional group, but the particular site is a functional group. For the first case, in this molecule, if you look at this molecule, we have this carbon triple bond carbon, which is certainly a functional group, and we know the name of this functional group to be alkyne. If we look at this carbon double bond carbon, again it's another functional group, and we already know its name to be alkene. Now this hydroxy is another functional group for this molecule, which is called the alcohol. So overall we have three functional groups in this molecule. Now let's discuss the second molecule. Here, if you look at this oxygen, which is surrounded by two carbons, so it must be an ether functionality, because we know the general formula of ether is ROR, where R and R, where R is the side chain of carbon. So this is an ether, and this C double bond O is called the carbonyl. But wait, we have to define that carbonyl, which carbonyl it is, because the carbonyl is present in the aldehyde, in the ketone, carboxylic acid, ester, amide, acid halide, acid anhydride, and imide. So we cannot just say that this is carbonyl. We have to tell whether this is the aldehyde or ketone or whatever the names I have mentioned. So to distinguish between those carbonyl compounds, we know that when the carbonyl is directly connected to two carbons on both sides, it is a ketone. So this particular carbonyl is ketonic in nature. So rather than just mentioning carbonyl, we have to mention the ketone. Now let's discuss the third case. Here this NO2 is a functional group which is called the nitro, and this aromatic ring is another functional group which is called the arene, and this is the benzene ring, but the functionality is called arene. And again this C double bond O is a carbonyl, but when it is directly attached to hydrogen, so overall it is called the aldehyde, which is called CHO. Now let's discuss the second question, which was which was asked about the transformation of these six reactions and these six molecules, and whether they are the oxidation, reduction, or none. With none, it does not mean the reaction does not occur, but with none we simply mean it is not the oxidation and not the reduction. So with the oxidation, we have already know a few definitions of the oxidation, such as the decrease in number of hydrogens or the increase in number of oxygen, or the most famous definition is the loss of electron. All definitions correspond to same concept, but we will discuss the definition of oxidation with a new concept, that when we have the increase in number of bonds between the carbon and a heteroatom, the process is called the oxidation. And then we have the decrease in number of bonds between the carbon and heteroatom, it is called the reduction. And remember, uh, with the heteroatom, we mean any atom other than carbon and hydrogen. Now let us discuss the first transformation. Here, if you look at this bond between the carbon and oxygen, which is a single bond, but after the transformation it has become a double bond. So it is the increase in number of bond between the carbon and the oxygen. So this process is called the oxidation. Now let's discuss the second case here. The CO transformed into CCl. The number of bond between the carbon and heteroatom was 1, and still we have one number of bond between the carbon and heteroatom. So this transformation is neither oxidation nor reduction. So we had better call it none. Now let's discuss the third transformation. Here this is an alkene and we have this haloalkane. Here basically if you consider this carbon which is attached with the hydrogen, and that is no heteroatom here, so zero bond between the carbon and heteroatom, and here we have one bond between carbon and heteroatom. And yes, this is oxidation from this carbon's perspective. But wait, the other carbon which has the hydrogen here has been added to further hydrogen. So this carbon has been reduced. Though one carbon has been oxidized and the other carbon has been reduced, so the overall impact is none, because we are not asked about the individual carbon. Rather, we have been asked to indicate the whole transformation is whether oxidation or reduction. For the compound D, transformation D, we have the three bonds with the heteroatom. This carbon has a double bond with the oxygen and single bond with the nitrogen. So overall, we have three bonds with the heteroatom, and in the product again we have three bonds with the heteroatom. Carbon and nitrogen has a triple bond between. So overall, this is none. Now let's discuss this case. Here we have carbon and oxygen double bond which has been lost. So this is reduction, because we have decrease in number of bonds between the carbon and the heteroatoms. In the last transformation, again we have three bonds with the heteroatom, which was same as the case for the transformation D, but in the product we have this carboxylic acid which is also three bonds with the heteroatom. So the overall there is no oxidation and no reduction, so we had better call it none. Now let's discuss the question 3, which was asked about the type of carbons, uh, whether they are 0 degree, 1 degree, 2 degree, 3 degree or 4 degree against each carbon in the molecule. So before starting in this question, let us recall what 1 degree carbon is, which is called the primary carbon. Basically it's a carbon that is directly attached to one carbon. So this degree, one in the 1 degree, the one refers to the number of carbon which is attached with this carbon. For the 2 degree, the carbon attached to two carbons. For 3 degree, the carbon attached to three carbon, and so as for the 4 degree. With 4 we mean carbon attached to four carbons, and we cannot have the 5 degree because carbon cannot be attached to 5 carbon, because carbon has the valency of 4. So we have only 4 options, whether carbon attached to one carbon or 2, 3 or 4. And remember, when carbon is attached to one carbon, it does not mean that that's the only case. The remaining 3 valencies must be satisfied with the other atoms. But with carbon, we have only one connection, so it is called the primary carbon. However, we have one more case where the carbon is not connected to any carbon, rather it is connected to some other atoms. We call it 0 degree, which is called the super primary carbon, because there is no connection between the carbon and carbon. So we call it 0 degree carbon. So these are the 5 types of carbon which any carbon has in an organic molecule. So now let us discuss the compound A. Here, if you look at the first carbon, it is connected with one carbon and 3 hydrogens. And the hydrogens are not being shown, but they are obviously present with this carbon. So this carbon is connected to one carbon, so it must be a 1 degree carbon. So if you look at this carbon, it must be 2 degree carbon because it is connected to with two carbons. However, if you look at this carbon, apparently it seems to be connected with one carbon and one carbon. So you must be thinking that it's a 2 degree, but it is a 3 degree carbon, because this carbon is doubly bonded with this carbon. So each double bonds mean two single bond. So overall, this carbon has connection with uh, three carbons. With three, I mean to say one carbon through single bond and one carbon through double bond. So one double bond corresponds to two single bonds. So as the case for this carbon, which is again 3 degree in nature. If you look at this carbonyl carbon, this is connected with this carbon and this carbon. So it is a 2 degree carbon. Same is the case for this carbon, which is secondary in nature, that is 2 degree. However, if you look at this carbonyl carbon, it is connected to only one carbon, so it must be a primary carbon. So if you look at this carbon, it is connected with two carbons, so it must be secondary carbon. If you look at this carbon, it is connected with four carbons, one carbon here, one here, one here, and one here. So it is a 4 degree carbon, that is called a quaternary carbon. If you look at this carbon, it is connected to only one carbon. The other three valencies are satisfied with the two hydrogens and one oxygen. So it is a primary carbon, that is 1 degree carbon. And the remaining three methyl groups, this, and this, they all are 1 degree in nature because they are connected to only one carbon. Now let's discuss the second molecule. So if you look at this carbon, it is connected with one carbon and one carbon. So it is a secondary in nature. So it is called the 2 degree carbon. And if you look at this carbon, it is a single bond connected with this carbon through single bond, connected to this carbon through single bond, and connected to this carbon through double bond. So as discussed in the previous case, one double bond corresponds to two single bonds. So overall, this carbon has a connection all over with the carbons. So it is a 4 degree in nature. If you discuss and see this carbon, it is tertiary in nature, that is 3 degree carbon, because one single bond with this carbon and one double bond with this carbon. So overall, it's a tertiary in nature. And this carbon is a 4 degree because it is a single bond carbon connection, and a double bond carbon connection. What about this carbon? This carbon is a connection of single bond and a connection of single bond with these two carbons. So it is a 2 degree carbon because the other two bonds are satisfied with the nitrogen, not with the carbon. And what about this carbon? This is again secondary in nature because this carbon is doubly bonded with this carbon and the other two valencies are satisfied with the oxygen and nitrogen. Now, if we look at this carbon, which is lying between two oxygens, uh, which has no connection with any carbon, so it must be 0 degree in nature, which is called a super primary carbon. Now, let us discuss this carbon. It has a connection with one hydrogen and a triple bond with the carbon, so it is 3 degree in nature. And this carbon is 4 degree because it has a triple bonded carbon and a single bonded carbon. Now, if you look at this carbon, it is a triple bonded nitrogen connection and a single bonded carbon connection. So this is called a 1 degree carbon. And this carbon is connected to two carbons, so it is 2 degree in nature. And this carbon is connected to one carbon, so it is primary or 1 degree in nature. Now let us discuss the fourth question of this assignment, which it was it was asked the type of carbon with in the connection with the sp3, sp2, and sp hybridization against each carbon. So before attempting this question, let us recall what sp3 hybridized carbon is. Here we are not going into the detail of the process of hybridization and all their geometrical outcomes. Rather, we are just simply trying to grip the concept that the hybridized sp3 hybridized carbon means we have a carbon or connection of all four single bonds. However, if we have one double bond and two single bonds for the carbon, so this carbon must be the sp2 hybridized carbon. And if we have a carbon triple bond carbon connection with a triple bond and a single bond, it is called the sp hybridized carbon. These are the outcomes basically, but the whole concept is different, which we are not going into detail because this is not the topic of this question. So this is just a shortcut to recall what sp3 hybridized carbon is and what sp2 and sp hybridized carbons are. So by this token, if you look at this carbon, it has four single bonds, one to this carbon and three hydrogens, which are not being shown. So it has all four valencies satisfied through four single bonds. So this carbon must be the sp3 hybridized carbon. However, if you look at this carbon, it has two single bonds, one from this with this carbon, one to this carbon, and a double bond with this oxygen. So this carbon must be the sp2 hybridized carbon. So as for this carbon, because it has a two single bond, one double bond and two single bonds, and in fact all these benzene carbons are sp2 in nature because all have one double bonded carbon and two single bonded atoms and single bonds. Now let us look at this carbon, which is on the right hand side of the nitrogen. Again, this has four single bonds, so it is sp3 in nature. So as for the other carbons, because all have the connection of four single bonds. Now let us discuss the second molecule. Here the first carbon has CH3, has three hydrogen, then one carbon, so it is sp3 in nature. For the second molecule carbon, it is sp because we have a triple bond and a single bond. This carbon is also sp in nature. However, this carbon is sp3 because it has three carbons single bond and one hydrogen. This carbon is sp2 in nature, as we discussed in the last example. Again, this is sp2. This carbon is sp3 because there is no double bond shown here. However, this carbon and this carbon, they are sp2 in nature. If you look at this carbon, again this is sp2 in nature. This carbon is sp3 because of connection with two hydrogen and connection with two carbon, all through single bonds. This is sp3 in nature because there is no double or triple bond, so as the case for this methyl carbon. Now let us discuss the fifth and the last question of this assignment, and this was about the concept of the oxidation state of each carbon. So before solving, let us recall what the oxidation states of carbons are. When the carbon is connected with hydrogen, it has the oxidation state of -1 because the hydrogen has the +1 oxidation state, so carbon has the -1 oxidation state. And if the carbon is connected to carbon, it has the 0 oxidation state because carbon, the two carbons are same. When the carbon is connected to any electronegative element such as oxygen, nitrogen or halogen, chlorine, bromine or iodine, we have the +1 oxidation state because they have the -1 oxidation state. Here you must be surprising that oxygen is -2. Why I'm telling it's -1? Because we have shown a single bond with this oxygen. So this oxygen must also be connected to some other atoms as well. So with one bond it is -1, so this carbon is +1. So further concepts will be cleared when we do this example, this question, the part A of this question 5. Here, this first molecule, carbon, which is CH3, surely it has C connection with three hydrogen and one carbon. As discussed, with the C, we have 0 oxidation state. However, with hydrogen, we have -1 oxidation state. But we have three hydrogens connected with this carbon. So we have -1 for one CH bond, -1 for another CH bond, and -1 for the third CH bond. So overall, this carbon has the oxidation state of -3 because of three CH bonds and one CC bond. So we have to basically add all the bonds to calculate the oxidation state of a particular carbon. Here, for this carbon, this is attached with one carbon and a hydrogen and a chlorine. So with respect to carbon, we have the 0 oxidation state of this carbon, but with respect to hydrogen, we have the -1 oxidation state. However, with respect to chlorine, we have the +1 oxidation state. So -1 +1 cancels each other. So overall, we will be having a 0 oxidation state for this carbon in this particular case. Now, if you look at this third carbon, to calculate its oxidation state, let us recall what are the atoms from which it is connected. So this carbon is connected with this right-handed carbon and the left-handed carbon. So it has the zero oxidation state because of these two carbons, but because of these two chlorines, it has the +2 oxidation state, because with one CCl bond we have -1 on carbon, and with another CCl bond we have another -1 on carbon. So uh, 2 - 1, because of, sorry, two chlorines, we have the +2 oxidation for carbon. One CCl bond means one plus charge on a carbon. This CH2 has the -2 oxidation state because of two carbons have zero oxidation state, but two hydrogen has -2. Now let's discuss for this case. We have zero oxidation state because this carbon is connected with this carbon and this carbon, which have the zero oxidation state for this carbon, but it is connected with one hydrogen which is not being shown here and one nitrogen which is being shown here. So because of one hydrogen we have -1 oxidation state, and one nitrogen we have +1 oxidation state. So -1 and +1 cancels each other. We have the zero oxidation state. So as for the second case, they are the similar case. For the third case, we have two hydrogens, so we will have a -2 oxidation state for this carbon. This carbon will have the zero oxidation state because it is connected with the four carbons, and these all three methyl will have -3 oxidation state because they are connected with the three hydrogens and a carbon. So these are the oxidation states for each carbon in a molecule. This is another molecule which we have to calculate for the oxidation state. So let us start from this carbon. It has the zero oxidation state because it is connected with this carbon and this carbon, and which is the zero oxidation state. But this hydrogen, which is not being shown here, because of that hydrogen we have the -1 oxidation state, but because of oxygen we have the +1 oxidation state. So they will cancel each other. -1 and +1 makes the sum of 0. For this carbon, we have the zero oxidation state because it is connected to carbons all over. However, this carbon is -1 because it is connected with carbon through single bond and carbon through double bond, which is 0. But it is also connected with one hydrogen, and because of that hydrogen, it has the -1 oxidation state for this particular carbon. This carbon will have the zero oxidation state because it is surrounded by carbons all over. However, this carbon is is in the +2 oxidation state because it is connected with this carbon and this carbon. So because of these two carbon, we have the zero oxidation state. However, with connection with this nitrogen, we have the +1 oxidation state for one CN bond, but it's a double bonded CN bond. So -1 and again -1 makes the -2 for this nitrogen. So this carbon will be in +2 with the oxidation state. If you look at this carbon, we have the +2 oxidation state because it has double bonded with the carbon, which is 0, but we have two single bond with the heteroatom. So it has the +1 because of CN bond and +1 because of the CO bond. So 2 + 1 makes the +2. This is the zero oxidation state because we have two hydrogens here and two oxygens here. So with two hydrogens, we have the -2 oxidation state, and two oxygens, we have the +2 oxidation state. So -2 and +2 makes the sum of 0. For this carbon, we have carbon triple bond carbon. So this carbon is 0, has the zero oxidation state because of these carbons, but has also the connection with the hydrogen. So we have overall -1 oxidation state. This carbon has the zero oxidation state because we have triple bonded carbon and single bonded carbon. So carbon all over gives birth to zero oxidation state. For this carbon, we have as +3 because this carbon is in the connection with the carbon, which has the zero oxidation state, but we have connection with the nitrogen. So each CN bond corresponds to -1 oxidation state for the carbon, and because of the triple bond, we may consider the CN bond thrice. So each bond corresponds to -1 as discussed. So -1, -1, and -1 makes the sum of -3. If you look at this CH2, it has the -2 oxidation state because it has the connection with the two hydrogens and two carbons. With the two hydrogens, we have the -1 and -1 makes the sum of -2. For this carbon, it is connected with one hydrogen and a carbon, So because of one hydrogen, we have -1. However, with two nitrogens, because Cn and again Cn, two Cn bonds, we have +2 oxidation states. So the +2 and -1 makes the sum of +1. For this carbon, which is at the terminal, we have CH3 and nitrogen. Because of three CH bonds, we have -3 oxidation state for this carbon, but because of Cn bond, we have +1 oxidation state for this carbon. So -3 plus 1 is equal to -2. So that's all for the assignment 2. I hope you enjoyed.